We are looking at graphs of the sine and the cosine and then coming up with the equations. So if I had y equals 4 times the cosine of x. So normally the cosine has a period of 2 pi, and it starts at 1 and goes down to -1. What is 4 cosine of x going to do? So this is the original cosine. The 4 would have what effect? It's going to make it taller. So this is the instruction for cosine of x. So cosine of x is made up of a whole bunch of sticks of varying lengths. And this just says multiply every stick by 4. So we change the amplitude, and it will look like that. Okay? What if I add 1 on the outside? Then the whole graph gets shifted up 1. So take your regular cosine sticks, multiply every stick by 4, and then add 1 to everything. And if I subtract a 2, then it would come down 2. Okay? All right. What if I had y equals the sine of x plus pi over 2? What is that going to do? Left pi over 2. So the normal sine graph looks like this. But everything that happens inside is backwards. So instead of moving right pi over 2, we're going to move this way pi over 2. And then we get this graph, which happens to be the cosine graph. Okay. All right. What if I did 2x? We're going to go around the circle twice as fast. Right? So normally, in this distance, we do a full revolution. But what if I speed my dial up twice as fast? We're going to do 2 cycles in that same time frame. So you would think that 2 is going to stretch the x-axis, but everything on the x-axis works backwards. So we actually compress it by 2. And the formula is the period is equal to 2 pi over, we'll call it b, where this number is b. So if b is 2, I plug a 2 in that formula. 2 pi over 2 equals pi, which means we do a full cycle in pi units. Okay? Now, here's something that we haven't talked about that's a little bit weird. If you do a horizontal shift, a phase shift, and you change the period, then things work a little bit weird. So if you had this, that's not going to do what you think it's going to do. Okay? So you look at that and you say, okay, the period is half as big, and we're going to phase shift to the left pi over 2. But we never write that sort of problem in this form. We always write it in this form. Okay? Those are not equivalent. Right? These are not equal. And if I pulled a 2 out of this, it would actually be 2 times x plus pi over 4. So this one means you cut the period in half and you move left pi over 2. But this one actually means you cut the period in half and you move left pi over 4. So whenever you have a periodic function that has a phase shift, a left and right shift, and a period change, make sure you put the phase shift in parentheses and the period change on the outside. Okay? Otherwise, you're going to get the answer wrong. So let me show you what I mean by that. Okay, let's do this one first. is this a sine or a cosine graph? And the answer is either, right? But for these problems, we don't have any phase shifts. So for these problems, we're not shifting left or right at all. Okay, so this one is a sine graph, and the sine graph has an amplitude of 4. So it's going to be y equals 4 times the sine of, what is the period? The time it takes to do a full cycle is 3 pi. The period in this case is 3 pi. So P equals 2 pi over B. Period is 2 pi, or no, sorry, 3 pi. So we multiply by B, and we divide by 3 pi, and we get B is 2/3. So the formula is P equals 2 pi over B. So we know that the period is 3 pi, so I put a 3 pi right there, and then I get B is 2/3. So 2/3 x. Okay, let's do another one. And Dean, so another one. So here, it's going to be negative cosine of a full cycle is 8 pi. So we write 8 pi, that's the period, is equal to 2 pi over B. Switch places with those. B is 2 pi over 8 pi. So B is just 1/4. So 1/4 x. Okay, you guys handle that? So let's look at the next problem. Maybe. Okay, so these are a little bit harder. Here we have a vertical shift, we have a phase shift, and we've also changed the frequency. So we've changed the period. So the first thing you need to do is figure out where the center line is. Where on the y-axis is the center line? It's going to be 1. So this is my center line. Is this a sine graph or a cosine graph? And it could be either, but the easiest one in this case is going to be sine. And the amplitude is 3, but the graph is upside down, so A is -3. Y equals -3 sine of something plus 1. Does everybody understand that? So normally sine looks like this, but this one's upside down, which is where the negative comes in. -3 sine of something plus 1. So we actually don't have a phase shift in this case. We did not move left or right, but we did change the period. So how far is it from here to here? One full cycle. So the period is 8. So we stick it in the formula. 8 equals 2 pi over B. And then we just switch places with the 8 and the B. So B is 2 pi over 8, which ends up being pi over 4. And that's the number that goes in here. So pi over 4 x. Does that make sense? Okay, now we need to find one that has a phase shift as well, because those are harder. Okay. This one does have a phase shift. So center line. Center line is the x-axis, right? Now, is this a sine or a cosine? And the answer is either. All right? If we want to do a sine, then this is my full cycle, and it has been shifted to the left, and it's upside down, right? If I want to do cosine, then this is my cosine graph, and it has been shifted to the left as well. It just got shifted further. So I'll actually do both so you guys can see how to do them. Now, we need to figure out how big a cycle is. So I'm going to start here, and I'm going to end here. Okay? Well, how big is each mark on this axis? Well, this is pi. So how big is each line? 1/3 of pi. So each line is pi over 3. And then I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in this case, the period is 12 copies of pi over 3, which becomes 4 pi. I stick that in the period formula. Uh-oh, you confused? So each mark is 1/3, pi over 3, and one full cycle. So to go from here to here was 12 marks. So 12 copies of pi over 3 simplifies down to 4 pi. So the period is 4 pi. I stick that in the period formula, 2 pi over b. Swap the b and the 4 pi. b equals 2 pi over 4 pi. So b is 1/2. Okay, so my graph is -3 sine of, and here's how you need to write it. B is 1/2. And that goes outside the phase shift. How far did the sine get phase shifted? So here is my sine graph right here. That is one cycle of the sine graph. The negative flips it upside down. The 3 stretches it vertically. The 1/2 changes the period. But how far did the sine graph move left or right to get where it is now? It moved left 1 line. How big is each line? Pi over 3. And if we want to move to the left, I add pi over 3. Because the x-axis works backwards. So -3 sine 1/2 times the quantity x plus pi over 3. And really the tricky part is you need to make sure that the phase shift is in parentheses and the period is not. The period shift is not. Now, what if I wanted to graph this in cosine? So let's get rid of that. What if I want to graph this right here? Well, the center line is still 0. Okay. Is it upside down? No. So it will be y equals 3 times cosine of, the period is the same as the sine graph, right? So the distance from here to here is 12 marks. Each mark is 1/3. So we put a 1/2 here. And then an x. And how far is it from there to there? 4 lines. And each line is pi over 3. So we're going to add 4 pi over 3. Those two formulas are equivalent. -3 sine of all of that is exactly the same as the 3 cosine of that. All right, let's do another one. Oh, that's not what I wanted. Okay, we'll do this one. The center line is at 2. And here is the cosine graph. It's positive, so y equals amplitude of 3 cosine. Did I shift it left and right? No. But I did do a period transformation. The period is 1/2. So 1/2 is equal to 2 pi over b. Swap those. B is 2 pi over 1/2. How many 1/2s are in 2? 4. So this is just 4 pi. So 4 pi times x. Okay. Oh, and I forgot something. Plus 2. Okay, now let's find another one that has a phase shift. Oh, shoot. That one would have worked, I think. Nope. Here we go. Okay, let's do cosine. So here is a full cycle, right? And my center line is at 0. So the amplitude is 4. So y equals 4 times the cosine of something like that. Okay. How big is each mark? Well, this right here is 3 pi. And there are 1, 2, 3, 4, 5, 6 units. So 1 unit must be 3 pi divided by 6, which is pi over 2. That's how big each line is. Each grid point is half of a pi spaced out. Okay, so how many of those are in one period? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 12 pi over 2 is a full cycle, which ends up being 6 pi, is equal to 2 pi over b. Swap places with those. B equals 2 pi over 6 pi, which is 1/3. So this number is 1/3. Does everybody understand that? No? You get it? Okay. And then how far did we shift? Well, we started here, and we went right to here, which is 2 lines. How big is 2 lines? No. No. Each line is pi over 2. So 2 lines would be pi. How do I shift to the right pi? Subtract pi. So 4 cosine of 1/3 times the quantity x minus pi. Now you could do the sine graph. If you prefer, you could do this. So that is going to shift left pi over 2. So y equals 4 sine of, it's the same period, 1/3 x plus, yes, plus pi over 2. That is the same formula. Those are equivalent at every point. Okay. Let's look at this problem. So here, it's just a description of the graph instead of giving you the graph. So a buoy floating in the sea is bobbing in a simple harmonic motion. That just means if this is time and this is height, So the buoy is going to be moving up and down as the waves come, right? So over time, it's going to trace out a sine graph or a cosine graph. Okay. The amplitude is 14, and the period is 0.2 seconds. And at 0 seconds, the buoy is 0 inches high. And initially, it moves downward. So we start here, and then we're going to graph this. But it told me it went down. Okay. The height is 14, and the period is 0.2 seconds. So the graph would be y equals negative 14 sine of, so 0.2 equals 2 pi over b. Swap those. So, oh, well. So 0.2 is the same as 1/5. It'll be easier to do it this way. So this is 1/5. So we get 2 pi over 1 divided by 1/5. Flip the period, or sorry, b is 10 pi. So we put 10 pi here, and then did we shift it left or right? No. Did we shift it up or down? Nope. So that's the formula. Negative 14 sine of 10 pi over x. And that graph will perfectly model the height of the buoy as the waves come in. All right. That's it. Get to work.